Good afternoon, gentlemen. If you hear any little pitter-patters, it's my kittens, they're playing. But I wanted to go through and I wanted to do a sample problem of a limiting reagent with you. Now, this will look familiar as it is the one that was on the back half of our combustion activity. But this gives me the opportunity to go through the steps on how to calculate and solve it. So hopefully this will help you prepare for your test, well, your quest on Friday and Monday. So let's get into it. The first one, I'm dealing with if 35.0 grams of Al2SO33 is reacted with 50 grams of NaOH, determine the limiting reactant. Now you'll notice I'm given 35.0 grams of Al2SO33 and I'm given 50 grams of NaOH. These are found on the left side of my arrow. So right here, I'm only working with my reactants when I have this. So it is important to kind of notice that I'm only going to see these when I'm dealing with my reactants. Now my first step, so number one, is I need to put my given into moles right away. So right away, when I look 35 grams and 50 grams, I need to convert these before I do any steps. So let's convert them. So my first thing is I'm doing 35 grams of Al2SO33, and I'm going to make a train track. Remember, I'm always cross-canceling, so I'm going to do grams on the bottom, moles on the top. In 1 mole, I have 294 grams. And to solve for my moles, remember, I'm going to divide. So I put in my calculator 35 divided by 294. I hit enter. Oops. And I'm given 0.119 moles of Al2SO33. I don't really have the space to do the second one up there, so I'm going to do it down here. So this is a continuation of A. In my first one, I'm still doing my 50 grams NaOH, right, because I need that, and I need to get that to moles as well. I use the molar mass of NaOH, which is my 40 grams. I put that on the bottom, and I do moles, so I'm going to take 50 divided by 40 in my calculator. And I get 1.25 moles. Well, right away, I can't compare these numbers. My next step is I need to do a ratio. So I'm going to identify my coefficients, and I'm going to plug them in and divide that by the moles I calculated for. So in this case, because I don't have a number in front of my Al2SO4 or SO33, I'm dividing that by 1, so 0.119 divided by 1 will give me that same number. But notice I have a 6 in front of my NaOH. So I'm going to divide that here. So I'll take 1.25 divided by 6. You get a 0.208 moles. Now that I have that, to determine my limiting reactant, I'm going to circle the smallest number from this ratio. So your first step is you want to make sure your given goes to moles, and then you're going to use your coefficients. Right? So I'm going to compare my numbers. I have 0.119 moles for my Al2SO33, and I have 0.208 moles of NaOH. Right away, I can see my NaOH is bigger, so that means that my Al2SO33 is my limiting reagent. Now that I have my limiting reagent, this is going to act as my new given. Because number 2 is I need to determine the theoretical yield of AlOH3, but I'm not given a number. So the number I'm going to use will be the number I solved at the end of my limiting reagent, or here, my 0.119 in this case. So that's going to be my starting number. And this number's unit is the moles of that element. In this case, my Al2, SO3, 3. Now that I have that number solved, I'm going to make a train track. I'm starting at moles, and I need to end at moles of AlOH3. So I'm going to be at my mole island. I know it's hard to tell. I'm at mole island, and I put my moles of Al2O3 on the bottom, SO4 or SO33 on the bottom, and my moles of AlOH3 on the top. I'm going to look at my balanced equation to do my coefficients. So I have 1 on the bottom, 2 on the top, and I want to end in grams. So I have one more train track. I want to end in grams, so I'm going to put moles on the bottom. I give you the molar mass. So I put that at the top. And just like usual, I'm going to go through and solve. In this case, I'm going to take 0.119 times 2 times 78. And on the bottom, I only have 1, so I don't need to divide by 1. So I am given the number of 18.56 grams of AlOH3. Now that I have that number, this number represents my theoretical, right? That's always what I calculate. Now I could say, here's my actual yield, which is 16.8. To solve for this, I'm going to take my actual value, which is what I find in the lab, and divide that by the theoretical value that I solved for, and multiply that by 100. That will give me my answer for what I actually yield. So I'm just going to plug in my information. I put 16.8 at the top. I put my 18.56 on the bottom, and I'll multiply that by 100. To do this in your calculator, you're going to take 16.8 divided by 18.56, and then multiply that number by 100, and you should get 90.52%. Now, if you go through and you round differently, your answer might vary, but as long as it makes sense, then you should be golden. Now, those are all the steps that you're going to be doing in our class. That's all you need to focus on. So as long as you know how to do these steps, you should be successful. If you have any questions, please let me know. Come see me before or after school. I am here as a resource for you. I hope this helps, and I hope you have a wonderful day. Bye.